So model number 4, design for shear. So course outcome of this particular model is after successful learning of this model, that is design for shear, you will be able to analyze a pre-stressed concrete beam for shear, and you will be able to design a PSC beam for the shear force given. Okay, this is the course outcome. This is the ability which you get after proper learning of this module. Okay, design for shear. Here in this model, in case of problems, beam of specified dimension will be given, length of the beam, cross section of the beam, all the geometric properties of the beam will be given, and loading of the beam will also be given. Lay load of the beam will be given. Using all those data, you need to find what is the ultimate shear stress which will be induced into the section. Okay, that you need to perform in case of solving the problems. And there is one more variety of problems. There he will give you a particular shear force in which the pre-stressed concrete beam is subjected to. For that shear force, you need to design the shear reinforcement of the PSC beam. Okay. So to solve the problem, so you need to remember 2 to 3 formulae, okay, which I mentioned here. The shear stress. This is a well-known formula. Shear stress formula: tau V is equal to Vu into Ay bar divided by E into B, where Vu is the shear force acting at a point, whether it may be support or at the center of the section. Okay, wherever we are interested to find the shear stress induced, there we need to find the shear force. We use the shear force, and Ay bar is the first moment of area or the static moment. Okay, first moment of area means area into distance, area into perpendicular distance. Ay bar is nothing but it is first moment of area or the static moment about the neutral axis of a section. Okay, moment of area about the neutral axis of the section. Okay, that I will explain you in detail while solving the problem. And I is moment of inertia about the neutral axis, and B is the width of the beam. Okay, so this is the generalized formula. I think you are already aware of this both the formula to find the principal stresses and the shear stress in strength of materials. Already studied it. And in the problems, he will also ask you to find the principal stresses. What is the meaning of principal stresses? Which means the maximum and the minimum stress in which the section may undergo for the given loading condition. Okay, maximum and minimum stresses in which the section may undergo during for the given loading condition. Okay, for that also there is formula, that is fx plus fy divided by 2 plus or minus half of root of fx minus fy whole square plus 4 into tau v square. Tau v you will be determining by using this formula, and fx and fy are fx means fx means the stress in horizontal direction, x direction, horizontal pre-stress. Okay, and fy is vertical pre-stress. You heard about horizontal pre-stress, but you have not heard about the vertical pre-stress. See, if the shear stress acting on a PSC beam is exceeding the limit, then we will go for horizontal vertical pre-stressing system also. Vertical tendons will be incorporated into the beam. In that case, we will get Fy also. Otherwise, this Fy value will be 0. Okay, Fx is the horizontal pre-stress and Fy is the vertical pre-stress, and A is the area of cross section. The section of the beam given is a flanged section, or whether it may be the T section or it may be the I section. To find ultimate shear resistance or shear force carrying capacity of the section, we will use this formula, and this formula is given in the code book. Am I audible, students? Am I audible?
Yeah. Yes, sir.
Yes.
This formula is given in the code book in page number 46. Okay. Here you can see the same formula is there. Ultimate shear resistance of a flanged section. Here you can see 40, or it may be I section, or it may be L section. The section which has the flange. Okay, for that section, this formula is applicable. Okay, the BC naught is equal to 0.67 B into D root of FT square plus 0.8 FCP into FT. Okay, where FT is the tensile stress of the concrete. Okay, sometimes it will be directly given tensile stress. If it is not given, he will give characteristic strength of the concrete or the grade of the concrete. He will give using this formula. You can find FT. Okay, FT is equal to 0.24 F root of FCK. This formula is also given in the code book in the page number 46. Okay, of IS 1343 code book. Okay, it's given in page number 46. Then FCP is the compressive stress in concrete at centroidal axis, that is P by A. Okay, compressive pre-stressing force will be induced into the section. Thus, that compressive pre-stressing force divided by cross-sectional area will give compressive stress in the concrete. Okay, so this is about the theory part of the problem. Okay, we need model 4. In model 4 also is going to be very easy model. Here, as I said, all the data will be given. You have to use this formula. Okay, you have to use this formula, and you need to find what is the shear stress, what is the principal stress. Okay, if it is a flanged section, so what is the ultimate shear resistance? It will be asked. The whatever it is asked, you can find it. Okay, it is a direct step problems. Okay, all of you note down the first problem. All of you note down the first problem. Students,
Writing, sir.
today I don't have the writing pad. Please cooperate, students. Anyway, I will be explaining each and every steps in detail.
Sir, voice is not clear, sir.
Voice is not clear.
No, sir.
Now am I audible properly now?
No, sir. Same, sir.
For all it is the same, students?
Yes, sir.
Your voice is bit low, sir.
No? No, am I audible properly? Properly? Students, am I audible now properly?
Yes, sir.
Now it's okay, sir.
Am I audible now? Students?
Yes, sir. Audible.
Yes, sir.
ಅನ್ಮಿಟ್ ಮಾಡ್ಕೊಂಡಿಯಾ ವಾಯ್ಸ್
Am I audible, students?
Yes, sir.
Yes, sir.
ಸಾಯಂಕಾಲ ತಗೊಂಡ್ಬಿಟ್ಟು
Am I audible, students, now properly?
Yes, sir. Audible.
Yes, sir. Please proceed, sir.
Students?
It's audible, sir.
Am I audible?
Yes, sir.
Am I audible, students?
Hello, sir. Excuse me, sir. Hello. Excuse me, sir.
Hey, Shaukat, you are not audible to sir now.
Am I audible, students?
Yes, sir.
Audible,
You are
sir.
audible. Please proceed, sir.
ಆಕಿ ಹೇಳಪ್ಪ ಬೇಡ ಅಂತಂದ. Students, am I audible now? I'm logging
Audible,
to.
sir.
Now am I audible? Students? Anyone
Yes,
can
sir.
reply? Okay. I'm presenting from some other system, that's why. Okay, all of you write the problem.
Problem is not visible, sir.
Just a minute, I'll present it. Now, is it visible? Problem? I hope it is visible now. Right? I also write the figure. So as per the data given, I have written the figure. First write it and I'll explain it later. Done? Finished, students? I'm still writing.
Yes, sir.
Finished, huh?
Yes, sir.
Okay. So you just go through the problem. A concrete beam of rectangular section 200 mm wide and 650 mm deep is pre-stressed by a parabolic cable located at an eccentricity of 120 mm at midspan and 0 at the support. Okay. I written a cross section of the beam and the cross sectional dimensions are given 200 mm wide and 650 mm deep. Okay. And it is pre-stressed with parabolic cable. Okay. Parabolic cable having eccentricity of 120 mm at midspan and 0 at the support. Okay, the cable, parabolic cable, is having eccentricity of 120 mm at the midspan and 0 at the support. If the beam has a span of 12 meter, the span of the beam is given as 12 meter and carries a uniformly distributed live load of 4.5 kilonewton per meter. A UDL, a live load is given 4.5 kilonewton per meter. Find the effective force necessary in the cable for zero shear stress at the support section. Okay, here what he has done is he has given shear stress. He had asked to find the necessary pre-stressing force to cause zero shear stress at the support. Okay, he has given shear stress. How much he has given? 0. Okay, he said that find the effective force necessary in the cable for zero shear stresses at the support section. Okay, we need to identify a suitable magnitude of pre-stressing force P so as to produce zero shear stresses at the support. Means that tau V is equal to 0. Okay, we need to utilize this condition. For this condition, calculate the principal stresses. It is also asked to find the principal stresses. Anyway, if you come to know the shear, anyway, if you come to know about the shear stress given at the support is 0. Fx and Fy we will calculate, and we will also find principal stresses. Okay, for the same problem. Okay. So for the parameters given, I have written the figure here. I have written the problem statement. We need to find pre-stressing force P for zero shear stress. This is the case 1. Case 2, we need to find principal stresses. Okay. Now shear stress at the support is given. How much it is given? 0. Tau V equal to 0. Okay. Below you take that condition. You write case 1. You write case 1. Below that you write shear stress at support is equal to 0. Okay, case 1 you write shear stress at support is equal to 0. Below you write tau V equal to 0. Tau V equal to 0. Okay, tau V equal to 0 you write. Now for tau V we have the formula VU into AY bar divided by IB. Below you write, we know that tau V equal to VU into AY bar divided by IB. Okay, therefore VU into AY bar divided by IB equal to 0. This tau V is equal to 0. You equate this term to 0. Okay, you equate this term to 0. Now what we have to do is we have to find all these parameters and substitute. You will get the required parameter, that is pre-stressing force. Are you following, students? Are you following? Any doubts here? Reply. Are you following? You want me to repeat again, students?
No, sir.
Okay. It's a very simple problem. He has given one condition that shear stress at support equal to 0. To make shear stress at support equal to 0, what will be the required pre-stressing force in the cable? That is the question. You utilize that condition. That is tau V equal to 0. You write for tau V, VU into AY bar divided by IB is the formula. Therefore, VU into AY bar divided by IB equal to 0. Okay. Now first we will find this VU. Okay. We will find VU. What is VU? It is shear force. Okay. It is shear force at the point of interest. Which is a point of interest here? Support. Okay, support. We are interested to find shear stress at the support. So at support, what is the shear force we need to find? Okay. At support, we need to find what will be the shear force. Okay, you all know how to find the shear force. Okay, for that you write the diagram. You write the diagram. Here I written. Write this diagram, students. So before that, you calculate the total load, dead load and live load. You calculate. Dead load and live load you calculate first. Dead load of the beam is equal to cross section into density of the concrete. Cross section is given as 200 by 650. Okay, 200 by 650. Therefore, 0.2 into 0.65 into 24. If you do, you need to get 3.12 kilonewton per meter. Don't simply copy the answer. You yourself calculate it and cross check the answer whether check whether you are getting the same answer or not. Okay. Now we need to find this shear force VU. Okay. To find shear force, first you calculate the total load which acts on the beam. After knowing total load which acts on the beam, you can calculate shear force. Okay. Dead load of the beam 3.12 kilonewton per meter and live load on the beam is given in the problem, that is 4.5 kilonewton per meter. Calculate the total load. Calculate the total load. Total load is 7.62 kilonewton per meter. For that, you do the factorization, that is ultimate load you calculate, multiply by 1.5. So when you calculate the ultimate load, the answer is 11.43 kilonewton per meter. All of you getting this answer, students? All of you getting this answer? 11.43 kilonewton per meter?
11.62, sir. 11.62.
11.6. Okay, no issue, no issue. Okay, there is a small difference in the answer, no problem. You proceed with the same answer. 11.60 kilonewton per meter. Don't copy this formula. Okay, right now this is not applicable. Okay, this is not required actually. Up to here it is over, I think. 11.43 or 6 to whatever told by. Okay, now we have calculated the ultimate load. Now the span of the beam is given 12 meter. You know the total ultimate load which is acting on the beam. Write the figure. Write the figure. Write this figure. Span of the beam is 12 meter. And beam is acted upon by an ultimate UDL of 11.43 kilonewton per meter. If you got any other answers, that you incorporate here in the calculation. Some Shaukat Ahmad Bhatt told that he got 11.62. You take the same value, no problem. Now we calculate the reaction at the support. Total reaction will be
69.7, sir.
okay, 69 point. Okay,
72.
no problem. Yes, correct answer. Here I got 68.52, no problem. 1 or 2 difference you will get, no issue. Now
69.75, sir.
okay, 69.75, right answer. Now you got shear force or the reaction at the support. Okay, see, this is not a ordinary RCC beam, it is a PSC beam. Okay, as it is PSC beam, there will be force which is acting through the cable also. Am I right? There will be pre-stressing
Yes,
force
sir.
that will act through the cable also. Here I have written a diagram, you can see. Okay. I have shown a diagram at this portion. So while calculating shear force at the support, we should take into consideration of this pre-stressing force also. Okay. While calculating shear force at the support or at any other point, we should take into consideration of this pre-stressing force in the cable as well. Okay. Now we came to know about the reaction at the shear force at the support due to only external load as 68.52 kilonewton. Now what you need to do is you need to calculate shear force that will act due to the pre-stressing force in the cable. Okay, shear force that will act due to the pre-stressing force in the cable. Okay, now here the profile of the cable given is parabolic cable. Now you are determining the shear force. Okay, whatever the force which acts on the cable, it is along the cable, right? It will be inclined in nature. So what you need to do is you need to find vertical component of that pre-stressing force which is existing along the length of the or along the line of the cable. Okay, that is why it is written as P sin theta here. You can see in the figure. Okay, so shear force or reaction at support which is acting in upward direction minus this P sin theta will be the shear force at the support. That is VU. You are understanding?
Sir,
Summation
repeat
of,
once again, sir, please.
yes, I'll repeat it again. See here you have calculated the reaction at the support due to the load, external load. Okay, dead load plus live load. Okay, reaction you got it 68.58 kilonewton. Okay, so the shear force at the support is the summation of shear force due to the load, that is 68.58 at the support. What is the shear force at the support? At the support shear force is 68.58 kilonewton. Okay, and this shear force is corresponding to the load applied. Okay, this shear force minus vertical component of pre-stressing force in the cable, that is P sin theta, will give VU. Understood?
Sir.
Now you calculate P sin theta. Sin theta you don't know. Okay, inclination of the cable is not given here. What is the inclination of the cable? It is not given. But we have the formula to calculate the value of this sin theta for parabolic cable. For parabolic cable, sin theta is equal to 4E by L. Remember, okay, P sin theta. Okay, P, it is unknown. That only we have to find here in this problem. P into 4 sin theta is 4E by L. If it is a linear cable or if it is a triangular cable, then formula is 2E by L. Formula for sin theta is 2E by L. If it is a parabolic cable, formula for sin theta is 4E by L. Remember. Okay, remember. So the vertical component of the pre-stressing cable is equal to P sin theta is equal to sin theta, you remember, 4E by L formula. P into 4E by L. P is unknown. You keep as it is. Do the simplification. After that, here I got 0.04 P. Okay, you are getting the same answer. Okay, 0.04 P. Okay. Now the total shear force or the ultimate shear force which acts at the support section is the sum of shear force due to the external load, that is 68.58, and shear force due to the vertical component of the pre-stressing cable, 0.04 P. And one more thing you can observe with respect to the sign convention. Reactive force, it is acting in upward direction. So it is plus 68.58. Okay. Pre-stressing cable, when you take vertical component of this pre-stressing force, it will act in downward direction. You can see in the figure here written. So sign for this P sin theta is minus, and sign for this reaction is plus. So here it is 68.58 plus 68.58 minus 0.04 P is the ultimate shear force at the support section. Okay, the net ultimate shear force is the sum of shear force due to the load and shear force due to the pre-stressing force in the cable. Shear force due to the load is 68.58 kilonewton. Shear force due to the and sign convention are plus and minus. Okay, so here I got the final expression for shear force, net ultimate shear force at the support. V is equal to 68.58 minus 0.04 P. Is there any doubts in this step, students, before proceeding with the next step? Is there
What is
any
the unit? Unit, sir, unit.
It is shear force, no? It will be Newton or kilonewton. In this case, it will be kilonewton.
Yes, sir.
Any other clarifications required? Okay. Now, so in this formula, we got VU. Okay, I hope calculation of this VU is clear for everyone. Next term, what we have is AY bar. Okay, AY bar is the first moment of area about the neutral axis. Okay, A into Y bar represents area into distance. Area into distance represents moment of an area. The first moment of area about the neutral axis. For that, write the diagram. First moment of area which is lying above the neutral axis, and moment of that area about the neutral axis. Okay, you give shading to the area which is above the neutral axis. Write this diagram, students, and calculate AY bar. Area, total area is 200 into 325, which is above the neutral axis, into perpendicular distance 325 divided by 2Y bar.
10.56 into 10 power 6 mm cube, sir.
Okay, right. 10.56 into 10 power 6. Now you got AY bar. Next, you need moment of inertia. I. Moment of inertia, you can calculate it. VDQ by 12. VDQ by 12. Here I got 4.6 into 10 power 9 mm4. Check your answer as well.
Yes, sir. 4.57 into 10 power 9 mm power 4.
Okay. Now the moment of inertia is also known. B. Only the remaining term is B, which is nothing but width of the beam. It is given in the problem 200 mm. Now all the parameters are known. Take this condition tau equal to 0. Okay. Substitute all the parameters in this equation. Only P is the unknown. You calculate for it and tell me the answer.
1743.7 into 10 raised power 3.
Correct answer. Into 10 power 3 Newton. Answer will be in Newton because
Yes, sir, Newton.
so you convert it into kilonewton.
Then 10 raised power 3 won't be there, sir.
Yeah. Okay. Now first part of the problem we have completed. I got 1714.5 kilonewton. Okay. One or two differences. Okay. In your answer. There is one more question asked to find the principal stresses. To find the principal stresses, we know the formula. Just write this formula first. Write the case 2. Write the headline as case 2 headline as principal stresses. Principal stresses. There is sigma max or sigma minimum is equal to, write this formula, fx plus fy whole divided by 2 plus or minus half of under root fx minus fy whole square plus 4 2v square. Write that formula. Case 2, you write as determination of principal stresses. Write the formula. Now we will find each and individual parameters. Tau v equal to 0. It is given in the problem itself. Tau v equal to 0. Now what we need is fx and fy. Okay. Where fx is stress due to pre-stressing force in horizontal direction, which is calculated. Fx is equal to directly P by A, pre-stressing force divided by area, cross-sectional area. Fx equal to P by A. P is given. Sorry, just now we have calculated P divided by cross-sectional area 200 into 650. Substitute and you will get Fx value. How much you are getting Fx value?
13.4 Newton per mm square.
Okay, fine. Now Fy will be equal to 0 only because there is no vertical pre-stressing given. Okay, I think we are going to solve one particular problem where Fy will also come into picture. Okay, in rest of the problem, in almost all the problems, Fy will be equal to 0. Okay, if shear stress, actual stress in the beam exceeds the limit, then as we provide the pre-stressing cable in the horizontal direction, they will provide a pre-stressing cable in the vertical direction as well. In that case, only Fy will come into picture. Otherwise, it will be always 0 only. Okay, therefore, write Fy equal to 0 because there is no vertical pre-stress. Okay, now all the parameters are known. Just substitute. Okay, and calculate for sigma max and sigma minimum. First, you add both the terms. Then you subtract both the terms. Means first you fx plus fy divided by 2 plus half of fx minus fy whole square plus 4 tau v square you calculate. Then you change the sign minus. Then you calculate. You will get sigma max and sigma minimum. I have calculated. You can refer.
Sigma max 13.4 Newton per mm square, sir.
Yes, right. 13.4 Newton per mm square and sigma minimum. I think you will get 0.
Yes, sir, 0.
Sigma minimum equal to 0. So this completes the problem. So the very simple problems, as like in model 3 here, in model 4 also you have very simple problems. You can easily attempt. Shall I move on to the next problem?
Yes, sir.
Please note the problem. Problem number 2, you write. There I have written 1. Take 2 to 3 minutes time to write the problem. Finished?
Yes, sir.
Read the diagram. This diagram is not given. I have written as per the problem statement. Write all the things what I have written, whatever I have written in the diagram. I'll explain in detail afterwards.
Done, sir.
Okay. I'll just go through the problem. An unsymmetrical I-section bridge girder has the following sectional properties. Area of cross section is 777 into 10 power 3 mm square. Okay, it is mm square only. The total area of cross section is given. Area below you write area equal to 777 into 10 power 3 mm square. In the given data you write 777 into 10 power 3 mm square. Second moment of area. What is the meaning of second moment of area? It is moment of inertia only. Don't get confused. Second moment of inertia is also called as second moment of area. I is equal to 22 into 10 power 9 mm square. Write it in the given data. I is equal to 22 into 10 power 9 mm raised to 4. Width and thickness of top flange. The top flange dimensions are given. Width and thickness. Width is 1200 mm and thickness is 360 mm. That I have mentioned in the diagram. Width of the flange 1200 mm, thickness of the flange 360 mm. And the thickness of the web is 240 mm. That is also I have mentioned in the diagram. Thickness of web is equal to 240 mm. The centroid of the section is located at 580 mm from the top. Okay, the distance of centroid is also given. With respect to the top fiber is given. Okay, the distance of centroid of the section is 580 mm from the top. That is also I have mentioned. Okay, from the top the centroid is located at a distance of 580 mm. Okay, the girder is used over a span of 40 meter. Okay, span of the beam or the girder is given as 40 meter. I think you can write it in the given data. L is equal to 40 meter. L is equal to 40 meter. 40,000 mm. Then span of the beam is over. The tendons with cross section of 700 mm square. The cross sectional area of the tendon is given. That you note it in the data. Data given. Area of cables or the tendons is equal to 700 mm square. Then The tendons are parabolic with an eccentricity of 1220 mm at the center of the span and 0 at the support. Okay. Eccentricity at the middle span, at the center of the span, you write E is equal to 1220 mm. E is equal to 1220 mm. The effective pre-stress in the wires, pre-stress is given, stress in the wire, pre-stress is equal to, right, 800 Newton per mm square. Then tensile strength of the concrete is Ft. Okay, tensile strength of the concrete is represented by Ft. That is given as 4.5 Newton per mm square. In the given data, you mentioned this also. Estimate the ultimate shear resistance of the section, assuming the failure takes place when the principal tensile stress reaches a value equal to the tensile strength of the concrete. We need to find ultimate shear resistance of the section. Okay, we need to find ultimate shear resistance of the section. So here the type of section given is a flanged section, right? A I section is given. For I section, to find ultimate shear resistance, we have the formula VC naught is equal to BW into I by S into root of Ft square plus FCP into Ft plus P sin theta. Okay, this formula you no need to remember, it is given in the code book. Okay, before only I have shown that. Here you can see 0.67 BD into Ft square plus 0.8 FCP into Ft. Okay, and one more important thing I forgot here, the formula is given only this much. Okay, only this much formula is given. Okay, see here, whatever the formula given, this formula is for straight cable. Okay, whatever the formula given, it is for straight cable. When the cable is straight, theta will be 0, then sin theta becomes equal to 0. So this whole term P sin theta becomes equal to 0. That is why he has not given plus P sin theta here. Remember, students. Okay, whatever the formula given, it is given for straight cable. Okay, here in our problem, it is a parabolic cable having an eccentricity of 1220 mm at the center and 0 at the support. So for parabolic cable, it will come plus P sin theta. Okay, remember this. If it is a straight cable, only whatever the formula given in the codebook, directly write that much formula only and do the calculation. Okay, plus P sin theta, you should not forget if the profile of the cable given is parabolic or the linear or triangular. Okay, I hope all of you written this formula, where BW is the width of the web. It is given in the problem itself, 240 mm. Note it down, BW is equal to 240 mm. Moment of inertia is also given. It is given as 22 into 10 power 9 mm4. Okay, BWI over next S is static moment of area, that is AY bar, or first moment of area. Okay, now above the neutral axis, I think all of you written the diagram. Above the neutral, moment of area above the neutral axis, and that too about the neutral axis. Okay, moment of the shaded portion about the neutral axis, you have to find. Okay, that is only the S. Okay, S is nothing but AY bar. Okay, AY bar. Okay, now I will explain how to calculate this S, or static moment of area, or the first moment of area about the neutral axis. See here, there are two components. I mean, there are two rectangles. One rectangle which is with respect to the web, and one rectangle with respect to the flange. Okay, you take moment of both the rectangles about the neutral axis and add them up and you will get the total static moment of this whole area about the neutral axis. Okay, means moment of first rectangle about the neutral axis plus moment of second rectangle about the neutral axis will give static moment of this whole area about the neutral axis. Okay, so the moment of first rectangle, this height of this first rectangle means height of rectangle which is formed by this web portion. Height it is not known, you need to calculate it. You know the distance of centroid from the top fiber, that is 580 mm. 580 minus this thickness of flange, if you do, you will get height of this particular rectangle. In the red text I have written 580 minus 360 is equal to 220 mm. If you are not written, write it, because it is required to calculate the moment of the area. Okay, now moment of this first rectangle about the neutral axis is how much? Area of rectangle multiplied by perpendicular distance. Area of rectangle is 240 into 220 is the area of rectangle into perpendicular distance, means distance of centroid of this rectangle one from this point G, centroid of whole figure. How much it will be? Tell me.
220 by 2.
Yes, obviously it will be 220 divided by 2. Okay, in this way you will calculate area, first area moment of first area about the neutral axis. Similar way, moment of this flange about the neutral axis will be area of the flange. Area of flange is 1200 into 360 and multiplied by perpendicular distance of centroid of flange to the top neutral axis. How much it will be?
360 by 2 plus 220.
Yes, right. 360 divided by 2 plus 220 or directly 580 minus 360 divided by 2. Anything, any of the calculation is okay. Okay. Either you can calculate as 220 plus 360 divided by 2 or 580 minus 360 by 2. In any way you can calculate. Okay. The same calculation I have written here. Area of flange about the centroid of the figure. Area of flange is 1200 into 360. 1200 into 360 into perpendicular distance. I considered a total distance 580 minus 360 divided by 2. I have considered which from which I get distance of centroid of flange from neutral axis. Okay, 580 minus 360 by 2. Or else you can calculate 220 plus 360 by 2. You will get the same answer. Okay. Next, I calculated moment of this first rectangle, that is 220 into 240 is the area. 220 into 240 is the area into perpendicular distance directly height divided by 2, 220 divided by 2, that is 110 mm. Okay. Finally, after calculation, you will get 178.61 into 10 power 6 mm cube. You check the answer. Why it is mm cube? It is area into distance. Unit of area is mm square. Unit of distance is mm. So mm square into mm, it will come as mm cube. That is why unit as mm cube. You check the answer. Here I got 178.61 into 10 power 6 mm cube. Are you getting this that answer?
Yes, sir. 178.6 into 10 power 6.
Yes. Now in this formula, BW is known, I is known, S is known, FT is given in the problem itself. Okay, tensor stress is given in the problem itself of concrete, 4.5 Newton per mm square. Then FCP we need to calculate, right? FCP we need to calculate, where FCP is stress due to the free precessing force. Okay, stress due to the precessing force, which is P by A. Precessing force he has not directly given. He has given area of the cable. He has given stress in the cable. Okay, he has given area of the cable and stress in the cable. Area multiplied by stress in the cable will give Pre-stressing force that you calculate it. Pre-stressing force is equal to cross-sectional area of the cable multiplied by stress. Cross-sectional area is given as 700 mm square. Stress in the cable is given as 800 Newton per mm square. Multiplying both, you will get 560 into 10 power 3 Newton. Pre-stressing force.
Yes, sir. 560 into 10 power 3 Newton.
Okay. So next you calculate stress. P by A. P is 560 into 10 power 3 divided by area of the cross section is given. That is 777 into 10 power 3 mm squared. You just substitute, you will get the direct stress due to pre-stressing force. Here I got 0.72. Check your answer.
Same answer, sir. 0.72.
Okay, 0.70 Newton per mm square. Now BW is known. I we have I is given. S we have calculated. FT is known. FCP also just now we have calculated. FT is known. Okay. Next P already we have calculated. Sin theta we need to calculate. Okay. So for sin theta it is 4E by L for parabolic cable. Eccentricity is given, that is 1220 mm. Eccentricity is given as 1220 mm. Substitute and you will get sin theta value. Sin theta is equal to 4E by L. Sin theta value I got 0.122. Is that right?
Yes, sir. 0.122.
Yes. Now all the parameters required to calculate ultimate shear resistance are known. Just substitute and get the answer. VC naught. I got 211.59 into 10 power 3 Newton. Or 211.59 kilonewton. Got it?
Yes, sir.
Okay.
211.6 into 10 power 3.
Yes, correct. 211.6. Right answer. Okay, this completes the problem. Write down the next one. Next problem. Problem number 3. Done, students?
Writing, sir.
Okay.
Done, sir.
Okay. A simply supported beam of rectangular cross section 120 mm by 300 mm has a span of 10 meter. Span of the beam is 10 meter. Is pre-stressed with a parabolic cable which has a maximum eccentricity of 100 mm at midspan and minimum eccentricity of 20 mm at the support. Okay. At the support also the cable is having eccentricity and at midspan. Okay. For that I have written the diagram. Effective pre-stressing force in the cable is given as 300 kilonewton. P is given 300 kilonewton. The beam carries a UDL inclusive of 30 kilonewton per meter. Okay. So in this problem, it is asked to determine principal tension or the principal stresses at 0.6 meter from left support. Okay, from left support at 0.6 meter from left support and 20 mm above the centroidal axis. Okay, and 20 mm above centroidal axis. I'll explain you while solving the problem. You first write the diagram. You write a rectangular cross section and mention the given dimensions 120 by 300. Longitudinal section also you write. And you give eccentricity for the cable at the midspan as 100 mm and eccentricity at the support as 20 mm from the neutral axis. Okay. And you also draw a section XX at distance 0.6 meter from left support. Okay. At this section only we need to find the principal tension or principal stresses. Okay. Therefore, you draw a axis or you draw a section at 0.6 meter from the left support. Okay. And one more thing, here he said that the beam carries all inclusive UDL. All inclusive UDL means inclusive of dead load and the live load, 30 kilonewton per meter. Okay. For that you do the factorization multiplying by 1.5. You will get 45 kilonewton per meter as the load which is acting over the beam. Finished?
Yes, sir.
Now, pre-stressing force is given, that is 300 kilonewton, that you write here. Lateral load is equal to 45 kilonewton per meter. That also you write. P is equal to 300 kilonewton, which is nothing but 300 into 10 power 3 Newton, and lateral load is equal to 45 kilonewton per meter. Okay. See, in the question it is asked to find principal tension, which is nothing but sigma max and sigma minimum. For that we have the formula fx plus fy divided by 2 plus or minus half into fx minus fy whole square plus 4 tau v square. Okay, first we need to calculate tau v. Okay, the shear stress we need to calculate. Okay, to calculate this shear stress we have the formula, that is vu into ay bar divided by ib. Okay, to calculate the shear stress we have the formula, that is vu into ay bar divided by ib. Again we need to calculate vu, ay bar, I and b we need to calculate. That calculation I have done in the initial steps. Okay, I have done in the initial steps. Here one unique thing about this problem is, instead of asking to calculate the principal stresses or the shear stress at the support, okay, at the support, he had asked to find the principal stresses at 0.6 meter from the support. Okay, it has to find the principal stresses or the shear stress at a distance of 0.6 meter from the left support. And one more condition he has given is, and 20 mm above the central axis. 20 mm above the central axis. So you need to take, while taking the first moment of area, okay, or static moment of area, you need to calculate area which is existing 20 mm above the neutral axis. Means this shaded portion, moment of this shaded portion you need to take about the neutral axis, remember. Okay, so you write these two diagrams, and calculation of sin theta will also vary. See, this sin theta is equal to 4e by L holds good only for the support. Okay, sin theta is equal to 4e by L will holds good only at the support. Okay, if you want to measure the sin theta, means vertical component of the cable at any other point, you need to use the basic principle that I will tell you now. Okay, for that you write the diagram. Are you able to understand this diagram? Here I have written the neutral axis or the central axis of the beam. Okay, at the midspan, the eccentricity of the cable is 100 mm, and at the support, eccentricity of the cable is 20 mm. So the net height of the parabola becomes 80 mm. 100 minus 20, 80 mm. That also right. See here, at this particular junction, we need to find the sin theta value. Okay, sin theta is equal to 4e by L is not applicable for this case, because it is applicable only when you are finding stresses at the support. But here you are finding stresses, principal tension at 0.6 meter from the support. You have to use some basic principle. I will tell you. Write these two diagrams first. If you have any doubts in the diagram which I have written, you can ask. Okay. So this second figure, this is the neutral axis. Okay. From the neutral axis, the eccentricity of the cable is 100 mm at the midspan, and at support, eccentricity is 20 mm. Okay. The net height will be 80 mm here. Height of the parabola.
Done, sir.
Okay. Is there any doubts in these diagrams? Because referring to these diagrams only, we are going to calculate the next things. Okay. Now we have to calculate sin theta value. Okay. Sin theta, why it is required? To calculate the reaction. Okay. To calculate the reaction, tau v is equal to Vu into Ay bar divided by V0 to calculate this shear force at 0.6 meter. We need the sin theta value. Okay. We know the equation of the parabola. We know the equation of the parabola. Y is equal to 4hx divided by L square into L minus x. Write it. Equation of the parabola y is equal to 4hx divided by L square into L minus x. You take this variable x into the bracket. Okay. You take this variable x into the bracket, then it becomes 4h divided by L square into Lx minus x square. Okay. Now to calculate the sin theta value, you differentiate this equation of parabola with respect to x. Okay. Differentiate this equation of the parabola with respect to the variable x. Dy by dx is equal to sin theta. If you differentiate this equation, 4h by L square is the constant. Differentiation of Lx is L. Differentiation of x square is 2x. Okay. Therefore, sin theta is equal to 4h divided by L square into L minus 2x. The height of the parabola is 80 mm. H is equal to 80 mm. The length of the beam is given as 10 meter. That is 10,000 mm. And x is equal to 0.6 meter. We are interested to find sin theta value at a distance of 0.6 meter from the support. So the x is equal to 0.6 meter, which is nothing but 600 mm. Substitute everything, we'll get sin theta value. Tell me the answer. Sin theta value, tell me the answer.
Point 031.
0.028, sir.
0.028. What is the other answer? 0.031. Huh?
No, sir. 0.0281.
0.029.
0.0. Correct. Correct. 0.028 or 29 also. Okay, no problem. Okay. Now sin theta value you got 0.028. The P value is given, right? P is equal to 300 kilonewton. Now you calculate P sin theta first. First you calculate P sin theta. P sin theta you calculate. P is 300 kilonewton, nothing but 300 into 10 power 3 into sin theta value 0.028 multiply, you will get 8,400 Newton as P sin theta value. Check the answer.
Yes, sir. 8,400.
Yes. Now you calculate reaction. Reaction as WL by 2. Where load on the beam is 45 kilonewton per meter. Length is 10 meter. WL by 2. If you do, you check the answer. That is 225 kilonewton. 225 into 10 power 3 Newton. You are reading this answer?
Yes, sir.
Write the figure. Okay. Now the reaction. Now the shear force at 0.6 meter from the support will be equal to the reaction due to the loading, that is 225 into 10 power 3 minus the vertical component of this pre-stress in the cable minus P sin theta. Okay. Therefore 225 into 10 power 3 minus 8,400, you will get the net shear force at 0.6 meter from the support. 225 into 10 power 3 minus 8,400. If you do, you will get 216.6 into 10 power 3 Newton or 216.6 kilo Newton. Got it?
Yes, sir.
Now you got VU value, right? VU you got. What next? We need to find AY bar. Okay, that is first moment of area we need to find. Okay, for that you refer this diagram. Here you can see. Determine the principal tension at 0.6 meter from the left support and 20 mm above the central axis. Okay, you draw an axis at 20 mm above the neutral axis, and whatever the area which is remaining above that axis, now that you do the shading. Okay. Now while calculating, you need to calculate moment of this shaded area about the neutral axis. Okay. AY bar while calculating, you need to calculate moment of this shaded area about the neutral axis. What is moment of this shaded area about the neutral axis? Area of shaded portion. Area of shaded portion is how much? Width is 120 and depth is 130, not 150. Okay. Because it is 20 mm above the neutral axis. Okay, 150 minus 20, if you do, you'll get 130. So area is 120 into 130. What about the perpendicular distance? Means distance of centroid of shaded portion about the neutral axis. How much it is?
130 by 2. Sir.
130 by 2. That's it. See, you are taking moment about the
Plus
neutral axis. Plus 20. Plus 20 you need to do. So 130 divided by 2 plus 20 will be the y bar value. Means perpendicular distance value. Okay, the same thing I have calculated here. So 120 into 130. Okay, into 130 divided by 2 plus 20. Okay, check the answer. It is 1.326 into 10 power 6 mm cube. Okay. Now next you calculate moment of inertia. That is BDT by L directly. B is width of the beam is 120 and are you getting this answer, students?
Yes, sir.
270 into 10. Okay. Now in the TOE formula, VU is known. AY bar we have calculated, moment of inertia we have calculated, width of the beam is known. Just substitute everything, you will get for shear stress TOE, you will get. Calculate it. Substitute everything and calculate it. Check whether you are getting that answer or not. 8.86 Newton per mm square.
Yes, sir. 8.86.
Yes. Okay. Now, as per this formula, we got tau v. The next thing what we want is Fx. Okay. That is horizontal pre-stress due to the pre-stressing force, that is P by A. You calculate it, Fx equal to P by A. Pre-stressing force is known, 310 power 3. Area you can calculate 120 by 300. You will get Fx as 8.33 Newton per mm square. You are getting that answer, 8.33, students?
Yes, sir.
Okay. Next, vertical pre-stress Fi will be 0 because there is no vertical cables given. Vertical pre-stressing is not given. Fi equal to 0. You take it as 0. Okay. Fi equal to 0. Write this formula. Principal stresses is equal to sigma max or sigma minimum is equal to Fx plus Fi whole divided by 2 plus or minus half into under root Fx minus Fi whole square plus 4 tau v square. All the parameters required are known. They are calculated. You just substitute and get sigma max and sigma minimum. Tell me the answer. Tell me the answer, students. Sigma max you tell and sigma minimum also you tell.
Thirteen point nine five sigma max.
Yes, right answer. 13.95. Sigma minimum.
Minus 5.62, sir.
Yes, correct. Minus 5.62 Newton per mm square. Right answer. Okay. So this completes the third problem. If you have any doubts, you can ask. Otherwise, I will take the attendance. Okay, sigma max is equal to 13.95 Newton per mm square. Sigma minimum is equal to minus 5.62 or 63 Newton per mm square.